Today we're going to start learning about how to write some code for a very sort of like simple kind of predictive AI. So do you remember back in the old days when you used Google and there was no like AI summary at the top? But did you also know that in the old days when you typed in Google, it would try to predict what word you wanted to type next? Like if you typed green, it might fill out like Green Bay Packers for you. Did any of you ever remember that? So it would basically look through what other people had searched before that started with something, and it would sort of use like an old-fashioned version of AI to try to think of what would come next. Um, Except before we do that, though, just one little quick thing. Let's actually go back to um, let's go back to that website we were at last time. And remember, I was explaining to you it's difficult to match. Let me share the screen real quick. Remember, I was explaining to you that it's difficult to match the end of a line because on Windows, there's what's called at the end of a line on Windows, there's a carriage return, which is an invisible character that's represented by \R. And then there's a line break, which is \N. In code, you represent those by \R, \N. And those things are visibly at the end of each line on Windows. Now, there is no such thing in computers. You can't, when you're using a computer window, you can't actually do a carriage return because computers don't have carriages. Do you know what a carriage is for a typewriter? That's like the thing that holds the keys on it. And it can move left or it can move right. Actually, the keys don't move left or move right. The wheel that holds the paper moves left or moves right. So there is no carriage on computers, so there's really not even such a thing as a carriage return, but they still use it. So with the typewriter, when you move down, let's say if you move down, it wouldn't move. See, if I push the arrow key down, it moves from the end of the word side to the next line all the way down. With the typewriter, if you move down, it would actually move straight down to that spot. So if you move down, it would go there. That's called the carriage return. I mean, sorry, that's called that's called like going down a line feed. And the carriage return was moving the cursor from the end of the line back to the beginning. So since some computer systems have a carriage return and a line feed, other computer systems just have a line break because that's really all that there is on a computer is really just a line break. It's hard to match those. So can anybody think of an alternative way of matching what's inside of all the lines and avoiding the issue with the line breaks at the end? I'll give you a hint. It would be a set of a lot of different things. It'd be a character class with a lot of different things in it. So for example, if I wanted to match everything in these two paragraphs like this and break each match at the end of the line, last time I tried to do it like this, like period star \n or something like that, and it didn't work right. Remember that? It only got the first line. So is there any way maybe to get it to work? Well, I'll give you a hint. If you could do somehow a character class that had all the possible letters in it, now let me show you something cool, okay? ASCII table. This is a list of all the characters, at least the first 200, well, at least the first 126 characters. Let's find, oh, does it have a picture of the whole thing? Yeah, here's the whole thing. So open image, a new tab. There's all the characters for you to see. First character is null. They used to use the null character at the end of a string. Do you know why that's not a very good idea though? Because in order to find the end of a string, you had to count, you had to scan through the string every time, all the way to the end, which might take like 1,000 different steps. And then you finally, when you got to 0, then it'd be the end of the string. Nowadays, they usually represent strings just by the length of the string and then the data of the string. So you can immediately read how long the string is without having to actually read through the whole entire string. And then, what are some other values of ASCII characters? Like, for example, what's the character value of a space? That's 32. which in hexadecimal is 20. If you look through all the other things, these are all the other character values of ASCII, but the line feed is number 10, and the carriage return is number 13. So that's where those two are. So if I wanted to, I could type out all the character values in this entire list, put them into a character class, and then I could match what's in the line, everything except for what's line break and the carriage return at the end. But that would take forever though. So there's one thing I didn't teach you last time, which is how to do a big set of things that is everything but something. So watch this. If I do \r\n, and then I put a caret at the beginning, it only works if it's at the beginning. If you put a caret later on in the character class, then it will just treat that as a literal caret. So then, if you run that, it'll get everything except for a line feed. Now, there's one thing I forgot though. Why is it only matching a single letter at a time? Why is it only matching a single letter at a time instead of matching the full paragraph? Can anybody think of why? Because I forgot to put a quantifier after the character class that will match one or more. So let's do that. Perfect. Now it matched both paragraphs. So the first match was the full first paragraph, not including the carriage return or the line feed at the end. And the second match was the full second paragraph, not including either the carriage return or the line feed at the end. So there's some things in regular expressions that you can only do well, or maybe even only do at all, by using that caret, which means the complement of a certain list of characters. So that means everything except for a carriage return and a line feed. Now, technically, you don't have to use that complement character. If you wanted to, you could type in all 126 other possible ASCII characters like A, B, C, D, E, F, G, and so forth like that. But that would take forever. It's much easier and faster to just do everything but the carriage return or the line feed, one or more of them, and then they'll match all the paragraphs. So that's pretty cool. Okay, now let's move on to the next amazing thing. Who's excited? Okay, good, perfect. By the way, let me write down attendance real quick. So I've got Zoe the Great and Caleb. You're Caleb, right?
Yeah.
Caleb the Great, Marketa the Great, and Logan, is that you? Or Colin? Colin's that's you, right?
Yeah.
Colin the Great, and Logan the Great, and who's next to Colin? Is that what's your name? Isaac. Oh yeah, Isaac. Isaac the Great. And then LaShawn the Great. And then are you Arturo or Ignacio?
These guys are cool.
Okay, so he is here. Okay, perfect. Arturo. Okay, perfect. Good job, everybody. So I'm going to close this window, stop that window from sharing, and I'm going to open up a notepad file. So I think all of you are familiar with using Notepad now to write code with. It's way more simple than it seemed like, although I don't know if it's actually installed on this computer though. Maybe it got deinstalled. Oh, there it is. There it is. Now you don't even have to use this official Notepad++ program. You can use other things. Let me go ahead and install the update for it. Okay, it's a free source code editor.
Here we use VS Code for our programming class.
Yeah, that's fine. You can use whatever program you want that can open a plain text HTML file, which I just helped one of the students recently in my office, and they used whatever Visual Studio was for it, and it can open it fine. Anything that can open an HTML file as plain text and edit the actual text in it will work. Okay, so where did okay, there it is. So select language, English, next. By the way, it's always good to install updates in case there's security bugs. So even though it's using up an extra minute of class, it's still smart to do. So here are all the bug fixes. It's crazy because this program has been there like more than 20 years, and it's like every single month they still find new things to fix. Isn't that crazy? So let's go ahead and open a new file. I'm going to go through this really slow and show you what every function does, if at all possible. So first of all, and by the way, you are going to have to type this yourselves. So I will put it in the recording so you can scan through the video, but let me make sure I record it though. Share screen. I'm just going to share the whole screen actually to make it easier. You'll have to type it yourselves, and it will be an assignment as well. So first of all, we're going to start with the script tag. A script tag is just an HTML tag that contains, and now there used to have lots of different kinds of scripts, but there's pretty much only one scripting language that's still common on the web, which is JavaScript. So JavaScript beat out all the other ones. It was invented by Brendan Eich, who was one of the original developers of Mozilla. So script, and we're going to create a variable called pick, and it's actually going to be a variable that is a function. So variables in JavaScript can be pretty much anything, including functions themselves. So the pick function is going to take a number and change that number into a random integer from 0 to n minus 1. Why would that help? Why would it help to do that though? In other words, it returns a random index to an array with n elements. So that's what it's actually doing. So if you have an array with n elements, it picks a random index from that array. So let's end the script. And now you don't have to actually type this next part, but I'm going to just test that out so you can see what it does. So now when you save this file type, just do it as a normal text file, but make sure that you add HTML to the end of the name. And don't save it into the program files directory. Pick a different folder like the desktop or something, or the documents maybe. I'm just going to do desktop. Then we're going to call this one Super Mega AI version 0 .html. HTML, hypertext markup language. Now we're going to go to the desktop, try to find that file. So there it is, Super Mega AI version 0. Open it up. Now nothing shows because there's nothing visual that we've done in that entire page, right? We've only written a hidden script. We haven't written any content itself. So, but let's go ahead and test that formula though. Let's say this is just a test. You don't need to actually do this in your code. Let's say document.write pick 5 or pick 6 to make it sound like football. So there we go. Let's run that now. So let's go to the browser, close this window. Wait, where is that other window? Close. Oh, it opened in Edge, my fault. Because Edge is the default on this computer system. There it is. So if I reload it, it says 1, but next time it'll say 2. Can anybody tell me the range of numbers that it could print if I said pick 6? It returns a number from 0 to n minus 1. So what's the range of values it could return?
0 to 6.
So it's 0 to n minus 1. So if it says pick 6, what's 6 minus 1? Right. So it could return any number between 0 to 5. So if you keep doing it often enough, you'll see them all. 3, 1, 4, 1, 0, 4, 3, 5, 4. So that's because in a 6-element array. Yeah, so n is 6, so I'm calling it with 6. Pick 6, so n equals 6. And it returns any number from 0 to n minus 1. So 6 minus 1 is 5. That's because the computer counts starting with zeros, but it's mathematically, it's because the random function returns a random decimal number. Anything from 0 to 0.99999 with an infinite number of 9s. So the random function returns random decimal numbers basically. It never returns anything beyond 1. So what happens is you take that random value, multiply it by 6, and then it returns a number from 0 through 5.9999 to infinity. And then it math.floor rounds it down. So it rounds that down to anything from 0 to 5. Okay, so that's what that does. Now why would you want a function that picks something? Let's test it out even more. So let's create an array. I'll say data equals, I'll give it some words. Hi there, this is, okay, that's boring. Let's use some names. So give me some names of some celebrities that you like, or some football teams you like, or anything that you like. How about just people? Bill, George, Joe, Dan, Bob, Bill. I've already said Bill. Somebody think of another name. John.
Or,
What?
yeah.
What do you say?
Yeah.
Jeff. Okay, so Bill, George, Joe, Dan, Bob, John, Jeff. And now how do I extract that? That's a string. There's only one. That's not an array. How do I take the words in a string and put them into an array somehow? I'll give you a hint. It has to do with a regular expression. So we're going to use a regular expression, which we just learned about. That's one great reason to use them. So I'll say dot match. If you say a string dot match, and then you can put a regular expression, we're going to say \w plus /g. That's going to find everything that has a word letter in it, like a letter like I or J or anything like that. And it's going to find one or more of them. So it's going to match each of those words, Bill, George, Joe, Jane. The G will find them all. And then the match thing will return an array that contains all of them. So watch this. If I say document.write data, you'll see that data. And by the way, you'll see the data followed by a number after the last word of the data. So let's try that real quick. So let's go here. So close all those other windows. Now, why did it put the 5 right after the word Jeff? Anybody know why? Why didn't we be nice and leave a space? Because the computer will do whatever you tell it to, and we didn't tell the computer to put a space between the word Jeff and the word 5. So this thing right here, Bill, George, Joe, Jan, Bob, John, Jeff, is just the first instruction that we said. We wrote the data out. Then we said pick 6 or whatever after the data, and there was no space that we said to put in between it. So let's go ahead and put a line break, which is called BR. The BR tag in HTML is what you use to make a line break. Yes.
Would it also work if you put a space right after Jeff right there? Does it work like that?
Well, see, if I put a space after Jeff right there, that's not part of the word. So any of those spaces are actually just ignored. Yeah, so in fact, all those spaces are ignored. The only thing that's matched is the words themselves. Yeah, so, but that's a good idea though. But the thing is, it's not actually literally writing that string. It's writing the array. So there's that. Now the one is on the next line, and if I refresh it, it changes randomly to any number like that. So what if I said this? I'm just trying to help you understand what the code is going to be doing in a few minutes. What if I said document.write data bracket pick 6? So if I say data and then brackets like that, that picks an element of the data randomly. So it picks one of the data elements randomly. Now I'm going to change that pick 6 to actually be pick 60 or pick 25. And I'll explain why. So when you run it now, it says undefined. Why does it say undefined? There aren't 25 items in the list. So some of the time it will be defined like Joe. That time it happened randomly to pick the third element. But if it ever picks a number beyond the number of elements, like 10th or 15th element, it's going to say undefined. So most of the time, so this time it said John, refresh, undefined, refresh, still undefined. So that doesn't work properly. But what if I change it to something like this? Pick 5 or pick 6. Would that work? No, that wouldn't work either, because now one of them is going to be left out. Can anybody tell me which person will never be picked if I say pick 6? Jeff, because there's only 6 before Jeff, but Jeff will never be picked. So how do I make the program pick always the correct number of possibilities as how many things are in the array? I can say pick data.length. The length of an array is how many elements are in the array. So the length of the array is 7 in this case, but if I added another name to it, it'd be 8. So by saying pick data.length, it picks a random element from the array, anything that's in the array, and it always picks at the proper length. So you won't ever get an undefined value, and you won't ever miss one of the values either. So that's how you do, that's what that is done. So that's the first function that we have in the program, is a pick that picks a random thing. And let me give you a quick overview of this. So let me write this in plain text. So overview. In fact, let me do a pre-tag. Pre-style white space pre-wrap. Remember how I did that last time? That's just a way of writing a nice little text paragraph. So this is an overview of it. What is our strategy for doing predictive word prediction? Strategy for word prediction. Okay, first we will scan, which is called training, on a big input file of text, like a book. Okay, so do you understand that concept? So we're going to read through a big input file of text like a book. That's the first step. Next, we will have a user put in 2 words of input. So somebody will just choose their own words. The program will try to find where those same 2 words have happened in the training book or whatever, and then use what happens next in the book to decide what word to predict or whatever, to predict next. Just like if somebody had typed Green Bay Packers a lot of times on the internet and somebody types Green Bay, then you probably know it would be Packers that comes next. So does that all make sense to you all? Now, can anybody think of an issue with this overview strategy? Can anybody think of a big issue with it? This would take a long time, because what if somebody types 2 words? According to this overview, every time somebody types those 2 words, you'll have to look through the whole entire book trying to find those 2 words. That would take a huge amount of time. So if you're trying to predict, let's say, 1 page of a paper with like 500 words on it, you'd have to read through the book 250 times, right? Because for every 2 words that you try to predict, you'd have to read through the whole book again. So is there any more efficient way of doing it? Yes, there is. So we're going to store, note, to be efficient, we will just read the book once and store all of the 2-word combinations in a variable. Now, one big issue though. Can anybody think of another big issue? What if the same 2 words happen more than once in the book? Like what if sometimes it says like Green Bay? Is there any other thing that comes after Green Bay in the whole universe besides Green Bay Packers, do you think?
Ocean.
Yeah, maybe Green Bay Ocean, or something else that's in Green Bay, right? Is Green Bay a place? So there's got to be something else in that place besides just the football team, right? So obviously there could be something else that happens. So one big issue, other things can happen after the same 2 words, not just one. So the prediction needs to be weighted based on which one is most likely to happen. So that's a very complicated thing to do. What's a super easy and efficient way of doing that? What do you think? So do you know what the word random means? Everything has an equal chance of being chosen, right? So the word random is a lot of times misused in statistics. So if you have a random sample, that means truly random samples means that every point in the data set or in the sample space has an equal chance of being picked. But the thing is, that's not exactly what we want, because we want to have ones that happen more often to have a bigger chance of being picked, not the ones that happen less often. So how can we make it work? What do you think? So we have to actually, what we have to do is we have to store every time this is a simple way of doing it. This is not the only way. This is a very simple way though of doing it properly. Every time we find two words in a row in the book, we're going to add the word that comes next to them to an array that represents everything that can happen to those same two words. So let's say that the Green Bay happens 5 times in the training book. Now, by the way, did you notice that this program is trying to predict what I'm going to write next all the time? And I can actually tell it's slowing this computer down because this is a slow computer. So like sometimes it's lagging and not typing as fast as I really am. Okay, so I wonder if there's a way to turn that off, but let's say the Green Bay happens 5 times in the training book. When it's Green Bay Packers 3 times, and then it's Green Bay, Wisconsin. Is that where it is? Or that's, I don't even know where it is even, but Green Bay, Ocean 1 time, and Green Bay Fall 1 time. So this, you can't use a random number to pick between those. If I store the data like this, 3, 1, 1, I can't use a random number to pick that because it doesn't know that it has to have 3 times the chance for the first one. So what I could do though, remember what you did with when you tossed the dice, you listed all the things separately. So what if I just say Green Bay, what if I had one array called solution? Okay, so instead of doing it like this, I could have one array called the Green Bay array. And it just contained this. Packers, Ocean, Fall, dot, and it would like those would be broken apart into separate elements in the array, right? And then since Packers happens 3 times in that array, now I can do a simple random choice. And since the simple random choice would have an equal chance of picking any of those 5 items, now it would actually have 3 times as likely of a chance to pick Packers and only 1 in 5 chance of picking Ocean or Fall. So how does that strategy sound? So all I need to do is just simply create one simple array for each pair of words that happens and add to that array the word that happens next once every time the word that happens next happens. So if it happens 3 times, it says Green Bay Packers, you'll have 3 Packers in that array, and so forth. And then I can just simply use the pick function that I've already written. This pick function will just return a random one of those values. So that's the strategy. So we're going to use that strategy. Perfect. Okay, now we're going to write some more code. So we have the pick function, and now we're going to create a variable called prefixes. And then we're going to create a variable called words. And then we're going to create a variable called get words. Get words. And it's actually a function. It takes a string is plugged into the function, and then it matches the string just like we did before. Sorry, my fault. I forgot something. S.match. It's a regular expression. It takes anything that's not a space character, like, because there's words in books sometimes that have lots of strange letters in them. And even punctuation, even. We're going to just read the punctuation and the words all together. And then any space after the word as well. And then it matches it globally. So that's a way of matching the complicated, even like new paragraphs and everything like that. It's going to match the entire word as well as any spaces or punctuations, and even the spaces after the word are going to be matched, just in case there's some word spacing in the book. So that's going to get the words in the book. And then we need a function that trims off the extra white space around the words. So this is going to take a string and S is going to have any white space at the beginning of it or the end of it get eliminated. Actually, any white space in it actually just gets eliminated. So what does the replace do? The replace function takes a string, replaces anything that matches the regular expression with whatever you tell it to replace it with. And the little s means white space. So anything that has one or more letters of white space will be deleted from the word. So that's that. And then we're going to encode this. What this does is it takes two words, A and B, and it trims any white space out of the first word, and then it separates the two words with one space, and then trims any white space off of the second word, like that. Now we're going to make the critical function. This is the one that actually trains or learns from the book. So this is the function that actually studies the book and learns from the book. So variable study, it takes a string, which represents the book, as its input. And then it has a variable called I. That's just an index variable that it's going to be using later on. And then it takes a string that's input into it, and it gets the words out of the string. Then it defines the words, which are these words are the ones up at the top. By the way, why is this variable words and prefixes? Why are these two variables defined outside of the study function? Why do you think those two variables are defined outside the study function? It's because once we study the book, once we train from the book, we still have to have what we learned about accessible outside the scope of the function itself. So we have to have a predictive function later on that's going to use those words and those predictions that it got studied from the book in order to predict what will get printed next. Because we don't want to study the book every single time we need to make a prediction. We're going to study the book just once, and then we'll be able to make as many predictions as we want to. So, so it's going to initialize the words in the book to an empty array. Bracket, bracket means an empty array. And then it's going to initialize the prefixes to an empty object. That object is something that can contain keywords like, for example, Green Bay. And in fact, it can not only contain keywords, it can actually assign each of those keywords another array of their own. So like Green Bay can be an array that stores all the words that comes after Green Bay. So there's that. Then we're going to go through the string. There's a word that says called map that just goes through the string one thing at a time. S.map word arrow words.push word. So that just takes all the words you found in the book, puts them into the words array. Then we're going to have another loop, and it starts with the third word. By the way, the third word in the book is actually called the tooth index, or the second index. The 0th index of the book means the first word. The first index means the second word. This I equals 2 index is actually the third word. So starting with the third word in the book, what's special about the third word in the book? That's the word that comes after what? The first two words, right? What's special about the fourth word in the book? That's the word that comes after the second and third word in the book, right? So starting with the third word in the book, every word in the book, starting from the third word to the end, is always the word that happens after the two words before it. So starting with the third word in the book, and then going until the end, you're going to have a loop. And then you're going to capture the phrase of the words that are the two words previous to the third word. So variable phrase equals encode si minus 2, si minus 1. Those are the two words before the third word is the word index minus 2 is the word two words before. Si minus 1, that's the word one word before. If you encode those two words together, that's this function right here. It takes the first word you put into it, puts a space, and then the second word. So basically it's taking the word green and the word bay, putting them together with a space and saying Green Bay. So that's the phrase that comes before it. And then there's going to be a little if statement. If there's not that phrase yet, so if there's no phrase before that like that has ever been found in the entire book ever before, then you're going to create a new empty array. By the way, I forgot the ES. If there's not a, because it's called prefixes, not prefix. If there's no prefix with that phrase in it before, then you're going to initialize that to an empty array like that. So that you're only going to run that statement once. You're only going to run it once. Only if you've never, that means not. If you've never found that phrase before in the entire book, ever before, then you're going to initialize that to an empty array. You don't want to initialize it to an empty array every time. Why not? Why would you not want to initialize that to an empty array every time you found the phrase in the book? Because otherwise, if you found the phrase before in the book and you initialize it to an empty array, again, you'll be deleting all the data from before, right? And then you're going to add the word that comes after that phrase. So prefixes phrase dot push that adds something to the end of an array. And what it does is it adds the third word of the book to that phrase that was in the first and second words. Except this doesn't apply to just the third word, it also applies to the fourth word when I equals 3, and the fifth word and everything else like that. So every word in the book, starting from the third word, is always added to the array that is based on the 2 words that came before it. And by the way, I've also written this code before to do things using combination of more than 2 words at a time. You could store the prefixes for 3 words at a time and 2 words at a time and 1 word at a time if you wanted to. And then you'd have even more predictive ability. But just 2 words is enough to make it pretty cool. So there's that. And
You're missing a semicolon at the end of before loop, I think.
oh, actually, this one?
Oh, the very bottom.
That one?
Yeah.
Okay, so actually, you don't have to put a semicolon at the end of a curly brace, actually.
Oh, okay.
You only have to do it if it's the end of an assignment. So see how this one says steady equals this, and then it equals something. So that's an assignment statement. So I have a semicolon after that. But this is just the body of the loop.
Oh.
Yeah, so that's not an assignment. It's kind of weird. It's kind of weird. Like, for example, if you say in this language, if you say like function X or whatever, and then you like define the body of the function, you don't have to put a semicolon at the end. But if you just say variable X equals function, and then you put it like that, then you have to put a semicolon at the end. Now you don't really have to because semicolons are inserted automatically by like the syntax fixer. But if you try to put 2 lines on the same line without semicolons, then it will cause an issue. So I always like to put semicolons in them just so that if my text wraps somehow later on, like somebody pastes it into an email and it gets all the wrapping messed up, that it'll still work. But yeah, you don't actually have to have a semicolon there. But that's a good catch though. Okay, so let's go ahead and see. Now there's no way to see if this actually works because the study function doesn't produce any output at all. So I could run the study function and I get no output from it whatsoever. So let's go ahead and add one more function. Ready? So variable predict equals words. And then the words you put into the prediction function are used to so can anybody explain what this line is doing right here? What is that line doing? It's taking words, you're taking an array of words and you're plugging the whole array of words into the function called predict. And then the predict function takes those words and it runs a block of code from those words. And it calculates a variable called prefix, which is the word in the words that's the index of the length of the words -2 and the length of the words -1. What that does is it takes the last two words in the input and it combines them together with a space between them. And then it's going to check to see if those two words have ever happened in the book before. So variable guess equals prefixes, prefix, like that. And then, now sometimes those words might not ever be found in the book before. So we're going to do what's called a ternary statement. Guess equals, if the guess exists, if you assign a variable equal to itself, but then you put a question mark after that, that means if it actually does exist already, then if that question is true, then you'll go ahead and assign it some value. So if that guess does exist, then we'll assign the guess to be equal to a random pick from the length of the array that was found. If that guess does not exist, the colon basically means it did not exist. It does not exist, then we'll assign the guess to be a random word from the words that were input. That's what'll happen. So there's that predict function. Okay, perfect. Now, let's see how many more minutes we have. 6 more minutes. Let me see if I can type fast without making mistakes. So we just have a little bit of HTML to type. On submit equals return false. When you say on submit equals return false, that stops that form from submitting. So sometimes when you push enter or click a button, it submits the form. We don't want that to happen. So we'll have a button that studies the book input. And it says study. And then we'll have a button that we'll have a button that predicts the next word. Like that. And then we'll have a line break. And then we'll have big input. Big input. That's the training data. Text area. I'll say rows equals 15. Calls equals 50. And then name equals big. That's the important part, actually. This is just HTML that I'm typing right now. A line break, and then small input. Start with at least 2 words. Line break. Text area name equals small / text area / form. That. Okay, so let's run that. Theoretically, we'll have to check it for errors. So let's run that. And I don't know if there's an error console in the in this browser. Let me open this file in Google Chrome, because I want to check the error console just to see if there's any errors possibly. So there's the file. Let me do more tools, developer tools. Console. Okay, I don't see any console errors. That doesn't mean that there aren't any, but let's go ahead and wait, why is this? Oh, what's going on? Why can't I see the small input field? Here, 3 minutes. Well, we'll have to actually try this out next time, but let me go ahead and see if there's oh, does anybody see a mistake that's why my small input field was not showing? Notice, well, yes, that could also be an issue, but I also forgot to put the quote mark after the word name of the small. So this actually, the entire rest of the code is all considered to be part of the name of that. So I need to put my end quote like that. Now I could also put the rows and columns. I could say rows equals 10 and columns equals 50. So that one will be a little shorter than my other one. So there's that. Now I don't see any mistakes in this. I don't think it's actually gonna work though, but because there's probably are some mistakes, but let's take all this text up here, copy it into the big input file and click study and see if there's any errors in it. I didn't see any errors. Now let me put 2 words in a row, like times in, put that in the small input box and see if it can figure out what comes next. It didn't work. So it should have, if it would have worked, then when I typed that, it should have been able to figure out that the word that happens after times in is the word the. So let me go ahead and check the code between now and then next time to see what typos I made. Then we'll come back to this next time again. And then we'll have fun because we can actually put some books into it and then try to, and we should be able to get it to the point where it can start writing paragraphs on its own that sound kind of cool. So let's go ahead and stop the class for today. And then I will like email this file to myself so I can figure out what's wrong. And then I'll tell you next time, just so you know, because learning from your mistakes is always the most helpful thing. So see you next time.